What up, guys? So we're going to talk about centripetal force today, work some example problems. This is your equation page. If you have your notes, you want to go to, and you don't have to memorize what FC stands for. F sub C, it'll tell you centripetal force, and you're on page 2 of your notes, okay? Oh, this is the equation page only. So anyway, if you have your notes from, go to page 5, right? So you just finished watching the video. You have this filled out. This should be Latin for center seeking. You should have an arrow where your tangential velocity would be if you cut it right here, right? And you should show that where your centripetal force is always going, right? So let's work an example problem. So this is the equation right here. So this is on page 5 of your notes if you have the handouts. If not, you can take notes via Cami or let's just go back to this real quick. So in my course can look a little different than yours. Notes for second semester, you can use Cami or, oh my God, come on, Cami or Google Docs, right? So anyway, back into it. I don't want to make this video too long. So centripetal force, we know that is, so the units for centripetal force, as we know, it's a force, right? So force, the units we measure this in is newtons, right? And so mass, which is this one right here, is going to be measured in kilograms. Velocity, now notice we square that. That is measured in meters per second, though. That's the base unit. That's the SI unit. That's the international. And this is a new term right here. This puke yellow one I'm circling. This is new. Okay, so make note of that. Oh, that's a bad arrow. This is new. But this is radius, right? So what radius is measured in meters, like all things in distance, right? So, so if I do this, if I draw a circle here, I'm gonna do it right here. Actually, I'll do it over here. So like in an example of the video, right, the ball is traveling along that path, this poorly drawn, right, it's going this direction, okay? The radius is simply this. I'll just do this instead. This is the radius right here. That's the radius, right? So it's half a circle, right, if you forgot the word what the radius is, right? So if you didn't know what R stands for, you could always look that up too. So why does this work? So remember that a Newton, this is Newton's second law. I like to say F net equals M times A, right? So a Newton is equal to, this is a Newton, right? Is also equal to, it's the same thing as kilograms times meters per second squared, right? So why does this equation work? Well, all comes down to dimensional analysis. So if I plug this in, mass is kg, right? Velocity squared, now this is what's tricky, I squared it, right? That's going to be m squared over s squared because I squared it in the equation, guys. So in the equation I squared that. That's why these numbers are squared here. All right. So then I divide that by the radius, which is measured in meters, puke yellow, right? The radius is measured in meters. Now, if you do the math on this, okay, what's going to happen is, if you do the algebraic manipulation, this is going to cancel right here. One of those are going to cancel with this. This and this are going to cancel out. That's going to leave me with kg times m divided by s squared, which is a Newton. Okay, do you have to know that? No, I just think that's kind of cool to understand that. So let's work an example problem. So calculate the centripetal force. Oh, okay. So let's go ahead and underline that red. So F sub C is my question mark. We measure that in newtons. So this is my mass, right? And the car is turning around this curve at 25 meters per second. The radius, which is I'm making puke yellow here, radius is 50 meters. Okay? I just did step 1. Step 2, as always, when you're solving problems, write your equation. What most students screw up with this is they forget to square. So what I'm going to do, I'm a little OCD with my my parentheses here, right? So I'm just going to plug and chug, replace and substitute, right, underneath it. So I have, I'm just going to do it in the same, I'll do it this first time. 1,300 times my velocity squared, notice this is squared here, okay? So I have to square that, divided by my R, which is 50, okay? So where a lot of students screw up is they maybe they don't put the right parentheses in. So you just want to make sure you're writing this correctly in your calculator. 1,300 25 squared. I think I'm just going to, yep. So what I actually do, just to make sure I do it right in my calculator, you can do these in multiple steps if this is confusing, right? So if you don't like how I'm doing this, I'm about to show you real quick. Don't freak out. You can do it a different way. So this is a big force. That's why we typically do things in kilonewtons a lot of times. So because the newtons are get pretty big pretty quickly. Now, what I'm actually going to do here, just to make sure I don't have a calculator error, that tells me to do the top first, okay? So if you want to just do the top first to make sure you don't make this error, I just do 1,300 times 25 squared is equal to 812,500. That's just the top simplified divided by 50, okay? Divide that by 50. I get this number. My centripetal force in this in newtons is 16250 newtons. Okay. That means that's how much force is actually being applied to the tires and to the ground on the curve there, right? That's that friction force, which we'll learn later, is what's keeping you on the road. Okay. So I hope that helps. Okay, so I'm finishing up below the practice problems. Let's talk about the equation here. So this is in your notes. You want to follow along with me just to knock this out. So I'm going to go to my Jamboard real quick here. So let's just use the equation to figure this out. This is how I can figure out relationships if they ever ask you on a standardized test. As the mass of an object increases, right? So anytime they ask you stuff like this, so we're looking at mass. So we're looking at this right here, right? What I like to do is just plug in very simple numbers and only change that. So what I'm going to do, I'm going to plug in a 1 for everything. It's for 1 equals 1 times 1 squared divided by 1. Well, guess what that is? That's going to be 1. They're going to be equal to each other, right? I should leave this blank, sorry. That would be 1. That would be the answer, right? So, because they want to know what happens to the centripetal force, right? So let's just see. This is step 1. So if I increase the mass, so because it says the object's mass increases. So I'm just going to do another example right here, but I'm going to make it just make it a lot bigger, right? Let's make it 10. So I'm going to change that number from 1, 10 times 1 squared divided by 1. So 10 times 1 squared equals 10. So that's the force, right? So that's the force in newtons. So I should put that there, right? Just a real quick, so the centripetal force increases, goes up, right? That's an arrow meaning increase. Okay, so let's do this again. So let's go down a little bit to the next one. We talk about velocity. So as the velocity of an object increases, so remember when I talk about velocity, I'm just going to have to square it. So this is actually going to have the most impact on it, right? It should make sense. The faster you go around the curve, the faster you spin something, the more force you're going to feel on it. Think about that when you're swinging a string above your head. If you're barely going, there's barely any tension, barely any centripetal force, right? So yeah, we're going to talk about tension a little bit later with this. So now I just plug in numbers, the same one, right? If I leave them all 1, they're going to be 1, right? That's the first example I used right here. That's that example I used right there, right? So let's just go ahead and bump that up to a different number. Let's bump it up to 10 again. But this time I'm only going to change. So we have 1, that's my mass, right? Times, and this is my velocity in the equation, right? I'm going to make that 10, and I'm going to square that. And I'm going to divide it by 1 because we're keeping that the same. We're only changing one thing, okay? So that's actually going to give me, right, 100, right? So The answer to that is 100 newtons. So again, the centripetal force increases as well. Now, you can probably think about this. The bottom one here, just showing you two different radiuses, right? So we'll just go ahead and do these really quick. I'll do the one on the left first, okay? So let's just make everything 1 except for the radius. I'm going to do it 10 and 5 on this one, just for the visualization here. So on this one, the curve would be from here to here. Let's do this. I'm sorry, guys. Let's do this one first over here. So from there to there, that's the section of the curve. Anytime you go around a curve, if you complete the curve, right, into a perfect circle, you have a radius, and you can calculate this stuff, right? So this is the section of the curve I'm talking about. That's the section. Well, then I can calculate that. If that's on 5 meters, right? That little dot should be in the perfect center. Is it? Probably not. Let's make everything else 1. So in this problem, 1's my mass, 1's my velocity squared, then my radius is 5 in this one, okay? So that simplifies to 1 divided by 5, all right? So, you know, what that actually reduces to is 0.2 newtons. So now let's look at this. And I probably should have picked a bigger numbers for that, but whatever. Make everything else the same. 1 is the mass, 1 squared is the velocity. Now this time, I'm doing the second one over here, I'm going to use 10, okay? Well, that's going to reduce to 1 divided by 10. So notice, this should make logical sense, right? Is that now my force is less. So as the radius increases, everything else remains constant. The centripetal force goes down, decreases. That should make sense, guys, because this is the one here on the smaller, that's a sharper curve, right? Sharper curve, more centripetal force needed. So yeah, so hopefully that kind of makes sense with this. And we'll get into friction and all these forces also later. And now you're going to work some practice problems. So the practice problems, if you go to my student resources page, is right here. I'm about to highlight. That is B5 on the student resources page. How do you get to the student resources page? Go to my website, right? Go to dsmithscience.com, the book that you have bookmarked. You go to student resources, and it should be the one. It takes a while to load too, I'm sorry, but it's right here. So you're going to work these problems, and you're going to submit them, and this is proof that you've done stuff today. Also, if you're doing this on Friday, don't forget to do the, what's it called? This thing right here that I'm highlighting right now. Don't forget to do this today, okay? Just don't forget. Yeah, that's the lesson for today, guys, to do those things. So, yeah.
Go, hit it.
Oh, no. Are you serious?
No way.
Are you serious?